Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at an introduction to the Pythagorean Theorem, also known as the Pythagoras Theorem. And by the end of this lesson, you should be able to locate the hypotenuse of any right-angled triangle. You should be able to state the theorem formula, which says a squared plus b squared equals c squared. And you should also be able to locate the hypotenuse when given two shorter sides, which we also known as what? The legs. And then finally, you should be able to identify triangles that can use this theorem. Without much ado, let's quickly look into it. So let's first of all look at the anatomy of a right angle. Since we'll be working on right angle, we need to actually refresh our minds with what a right angle is. A right angle is just an angle whose measure is 90 degrees. All right. So if a right angle makes a triangle, then we mean it looks something like this. Then the third side. So this is a right angle triangle. The reason being that the measure of the angle over here is 90 degrees. You see, that is the main component. Because the measure of the angle is 90 degrees, we call it a right angled triangle or a right triangle. Now for a right angle triangle, let's look at the three sides that it has. So for this very side, that is the longest side, I'm going to change the color and then make it a red. Now, if you are to compare this side to either this or this, you realize that among the three, this is the longest side. You see, so for a right angle triangle, we call the longest side the hypotenuse. The longest side is the one that actually faces the 90 degree. So if this is our 90 degree, you see the side that faces it, this side here. That becomes our hypotenuse. Hypotenuse is spelled Hypotenuse. That is a hypotenuse. So for short, let's just call it the H. Let's label this side as H. Then the other two sides, we call them the legs of the triangle. You see, they are the two shorter sides that meet to form an L shape, or they meet to form the right angle. So this is, let's just let this be our A and this be our C. So now that we know the anatomy of a right triangle or a right angle triangle, let's quickly look at the Pythagoras theorem. Now, the Pythagoras theorem says that if you have a right angle triangle, take note, a right angle triangle, then the hypotenuse, that is the longest side, if we take the hypotenuse and then we square it, then it will be equal to the sum of the square of the other two sides. I told you the other two sides, we can call them the legs or the perpendicular sides. You see, so our hypotenuse squared is equal to a squared plus b squared. This is just the formula. This is what we call the Pythagoras theorem. There's a proof to it, and it's actually a simple geometric arrangement that I'll just be doing for you to understand. So just to illustrate the geometric proof, this is a triangle I have drawn over here, you see. And for this side, that is the leg over here, we are representing it with what? 3 squares, you see. Now, to illustrate this theorem geometrically, this is a triangle I have drawn over here, that is the white one. And what I've done is I have drawn a square, you see. So it is actually, for this side, we have 1, 2, and then 3. Now, in this square, I have actually extended it to form a 3 by 3 grid. which is also a square. And then we have 1, 2, 3, 4 with another 4 in this direction to form what? A grid of 4 by 4. And then I've actually done this as well. So what the theorem is saying that is that this type of formation is only possible if it is a right angle. You can never take an isosceles triangle or an equilateral triangle and then expect to draw squares of equal squares of this nature around it. In addition to that, if we are to add the number of squares we have here and then here, let's do add that and see. So we have 1, 2, 3, or since it is a 3 by 3, so you can say we have 9 over here. Then since this side is a 4 by 4, 1, 2, 3, 4, and then by 1, 2, 3, 4, then it's going to become a 16. So all together, we are saying a squared, that is the square of the sides. So a squared plus b squared to give us the square of the hypotenuse. Now the hypotenuse is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. 25 squared. You could have as well just say 5 times 5, giving us 25. If you have to add 16 to 9, it gives us 25. And that satisfies the theorem. This is just a rough proof. But all we want to understand and establish is that the square of the hypotenuse is equal to the square of what? The sum of the squares of the other two sides. As simple as that. Now with this said, let's look at how we can actually apply it to solve some questions. So our first question here says, a triangle has legs of 3 and then 4. We have to find the hypotenuse, that is C. So how do we approach this question? So for starters, let's choose to draw. Okay, so I'm coming to draw this triangle we have here. Now it says the legs are 3 and then 4. So I'm going to let this be one of the leg, then this other side be the other leg. And this here becomes my hypotenuse. So with that, I would let this be the 3 and the other here the 4. And our hypotenuse is what? C. Now, since it is a right angle triangle, we can use the Pythagoras theorem. And we know what it says. So we start by saying using the Pythagorean theorem. And what does it say? It says the C squared, which becomes our hypotenuse, will be equal to the sum of what? The squares of the other two sides. So C squared will be equal to 3 squared times what? 4 squared. So it's about making C the subject now. We have our C squared being equal to 3 squared gives us a 9, then we have plus 4 squared gives us a 16. So you still have our C squared being equal to a 9 plus 16 gives us a 25. C is what we want and not C squared. So applying algebra over here, we can say that C squared is equal to 25, all right. But since it's C, we want to find the square root of both sides. And with that, the square root takes out the squared and we'll be left with what? A C. So continuing here, we have C being equal to, then the square root of 25 gives us what? A 5. So whatever the unit is, we'll just put it there. So C, which is the hypotenuse, is equal to what? 5 units. We'll write that as our conclusion. So that will be just that. Let's take some few more examples to enhance our understanding as well. So our second question here is just like this first one. It says a right angle has legs of 3 centimeters and 8 centimeters. And we have to find the length of the hypotenuse. How do we go about it? So using the Pythagorean theorem once again, we are going to say that this 6 and then 8 are the legs. See, and then we use the hypotenuse as what? Any variable. So first of all, I'm going to write the parameters we've been given. So our parameters, we know the length of the legs are what? 6 centimeters and 8 centimeters. We are going to let the hypotenuse be what? H. So now we want to use the Pythagorean theorem. So we would say using the Pythagorean theorem, which says that what? The hypotenuse h squared is equal to the sum of the square of the other two sides. So that is a 6 squared plus 8 squared. Then we do our simplification. So h squared equals 6 squared gives us a 36. Then 8 squared also gives us a 64. And if you have to add the two, we have 100. Now we want our 100. So h squared can be written as 100 is just a square of 10. So since the squares are the same, then it simply implies that what? Our h is equal to what? 10. Or better still, right from here, you could also say we have h squared being equal to 100. Hence, let's find the square root of both sides. So the square root is taken out by this, and we have our h being equal to the square root of 100 gives us what? A 10. So it means the length of the hypotenuse is 10 centimeters. So our conclusion here says, therefore, the length of the hypotenuse is 10 centimeters. These and many more are the applications of what? Pythagoras theorem. We are going to end this lesson here, but in our subsequent lessons, we'll look at more challenging exercises that would enhance our understanding. As usual, I'll leave with some exercises so you try on your own just to test your understanding. So here are some questions. There are just 5 of them, and you are to apply what we've done so far to answer the questions. This Hard Beyond Numbers where we learn maths the easy way. I do hope this lesson was helpful. If this is your first time and you so do wish, you can choose to subscribe so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Take care.
That's right, you've reached the final frame. Let's celebrate this learning game. With every number, big or small, you learn to stand up straight and tall. The easy way, you found the key to solve the puzzle wild and free. So don't you ever be afraid of all the progress that you've made.